Today we have a SAT type problem, a geometry type. You should see something like this frequently when you take your SATs. And the picture is basically one of a parallelogram, and they're going to give you just a minimum amount of information. The ratio of the sides AP to PB is 2 to 3. And then the area of DAP, which is this triangle right here, is 20. And with that information, they expect you to find the area of this shaded region, DPC. Now, to do this problem, you have to know certain proportional rules for similar triangles. In geometry, you should have learned that when two figures, it can be triangles, it can be any kind of shape, as long as they're similar, the sides are proportional. And let's say that this side right here is like an A and this is a B. It could be any number. As long as they indicate that it's proportional or similar, then you can create this proportion. A to B will be the proportion of their sides or even their perimeter. And when you square the sides, you have the proportion of their areas. And if you turn this into a three-dimensional figure, you can actually find the proportion of their volume by cubing A and B. Okay. Now this is perfect for two shapes that are similar, but there's another theorem that you have to understand to do this. It's when you have two triangles meeting on one side, or they share one side. And if you take the ratio of their heights, and there are two heights here, if this is an A and this is a B, then because they share the same side, the ratio of their heights actually becomes the ratio of their area. And you can actually do this in a different way. Let's say that you have a triangle like this and a triangle that's connected right here, and it goes like that. And you'll notice that the green triangle, if I draw it again right here, the height is indicated from the topmost part to the bottom at 90 degrees, which happens to be the same height that this gold triangle shares as well, if you draw the height. So notice in these two situations, they share the same height. If that's the case, then the ratio of their base, we'll call this A and B, is also the ratio of their areas. Okay, so let me recap. When you have two separate triangles and they're similar, then this is the pattern you want to follow. The ratio of their sides, and if you square it, you'll have the ratio of their areas, and then if you cube it, you'll have the ratio of their volume. But when you have a situation like this where two triangles are touching each other or they're sharing the same height, then the ratio of their sides are the actual ratio of their areas. You don't have to square it. Well, guess what? This is exactly what we see here. This is a parallelogram. Maybe you can't see it right now, but if I do this, you'll notice that this triangle right here, the height of this triangle is this. Okay, that's the height of this left triangle here. The triangle on the right over here, the height is exactly the same. And okay. So since these two triangles share the same height, the ratio of their bases is the ratio of their areas. Well, the ratio of this triangle right here, the ratio of this side is 2. The ratio of that base right there is 3. So that means the ratio of their area of the left triangle to the right triangle is 2 to 3. We're given the ratio of this triangle right over here, which happens to be 20. So now you can actually find the ratio. Using the ratio, you can now find the area of this triangle right over there. We'll call this, just call that X, okay? So 2 to 3 equals 20 over X. And just do your math. 2X is equal to 60. And X is equal to 30. So what do we just do? We found the area of the other triangle right here. But the real question is, how do we find the area of this triangle here? Well, notice that this triangle also shares the same height as this triangle here and that triangle over there. So the ratio of the sides must be the ratio of their areas. Oops. So the bottom, notice, if it's 2 to 3, then this right here would be 5. So the ratio of the triangle from here to here will be 2 to 5. And so we just set that up. 2 to 5 equals 20 over, and we'll call this part, we'll just call this y, okay? And so we just do the math. 2y is equal to 5 times 20 divided by 2, and this will be 10. So y is equal to 50. So the area of this is 50, and that's how you find the answer to this problem. I know in the beginning we did not have to find the area of this right side. We could have just jumped straight in it, but I wanted to show you a comparison so that you can relate to this problem more easily. Where's my mouse? There it is.